In this video, I'm going to give you a quick introduction to pandas so you can just learn the core functionalities of pandas and the kind of things you can do with it. I notice when I teach people how to work with CSV files or files on their computer in general, people run into all types of errors for one basic reason. And that has to do with actually finding the real location of a file on their computer. So in this, I'm going to work with a CSV file. I'm going to show you how you can get the file to be in the proper directory, the proper space on your computer, so that your Python code can actually interact with that file correctly. So I'm going to go somewhere on my computer to this part of the directory, the top level directory, and right click and just say paste. Now, when I try to paste the file into this directory in my code editor, it brings up this area here. Do you want to copy the file into this location? We'll say yes, essentially okay. And we see the file appears. Now we have the file on our computer. You can open this file, it's the CSV file. You can open it with maybe Microsoft Excel file opener that you have on your computer. Now we're going to go ahead and create a new Python file. We'll call it LO. Okay, and we have that there. So let's close this file for now, or let's close this directory for now. But before we do, I want to show you that we have our iris CSV. You see that they are right beside each other in the same directory. This is what you want when you're working with files in your computer. The code is the same directory as the file. It's 9% of the errors people have while trying to open a file. Pandas is the library that helps us to do data manipulation in Python. Install pandas. So we're going to use this command pip install pandas, and it says requirement already satisfied because I've already installed pandas previously. Import pandas into our Python script. Import pandas as PD. For us to be able to work with this file, iris.csv, we need to read it into our computer program. Let's look at the file for a little bit. What you see on top here, these are the column names, and you see this value corresponds with this value. This corresponds to this column, while this second column name here. This is how you're able to understand how a CSV file opens up in a code editor. And of course, the last column, species, corresponds with these unique names here. Now, I'm going to take you back to the code where we read this file into pandas. We're going to call the file df. You can call it whatever variable name you want. We'll say pd.readcsv. Within pandas, you can read in CSV files, you can read in database files, you can read in Google BigQuery, you can read in HTML, so many things you can read in. You can read in Excel files. These are just some of the options here of what you can actually read in: SQL, Stata, table, XML, Parquet files, JSON files, so many. We're not worried about them because we know we have a CSV file. Let's provide the directory or the file path to the file. So you can say file path. Now we're able to just give it this direct name as a string because we have it right beside the script we want. If it were somewhere else, we would have to pass in the actual directory to it. So this is why I usually advise the easiest thing to do is just have your CSV file right there beside your code. Save you the stress. Let's put in a print command here. Let's run this, right click, and it says CSV file has been loaded. What that means is that this line of code, line 3, was successful. So it successfully imported pandas. It read in this as a CSV file, and it was able to print this because this did not give us an error. Now, if for example, we put in a file name that does not exist, let's just put gibberish over here. This is going to give us an error, and this is not going to print out. But let me show you. Let's run it. Now, it gave us an error. A key part of programming is understanding the error that you have. Whenever you have traceback, you know you've done something wrong, right? So this is the error file. Most times it's usually read on most code editors. And now we see the error here. File not found error. Essentially saying, okay, we searched through your computer and we searched it everywhere and we were not able to find this file. That's what the file not found error means. And then, if you look at this, it says no such file or directory, and then gives you the name. So whenever you find this error, maybe you're working on a project by yourself, just know either the file does not exist on your computer or it's in a directory that you're not properly passing the address to. So those are some of the common errors I usually find people make when they start working with files in Python. Okay, let's fix this error. It's called iris.csv. Let's run this and we see that there are no errors. Now that I've successfully read in our files, we can do several things within Pandas by using some of its. First thing we can do is look at the number of rows and columns. For that, you're going to use the shape attribute to get the number of rows and columns that you have. Say df, let's print it. Say print df.shape. If we run this, it's going to give us this output. Now this output is just telling us, okay, the first number is the number of rows. Okay, so you have 150 rows in this data set. The second number is the number of columns. So you have 6 columns. Sure enough, if we count 1, 2, 3, 4, 5, 6, we do have 6 columns in this data set. So we've been able to use Python code to find out the number of rows and columns we have in our data set. Let's look at the columns we have in our data set. We'll say print the columns. Now this is going to print out all the column names that we have. So let's run it. It shows us that we have, this is the shape, and these are the columns that we have. So ID all the way to species. Now what if you want to look at your data programmatically? There are several functions within Pandas that can allow you to look at the heads or tail, the top of your file. The head function lets you do that, and you can just pass in a number and it's going to print out 5 rows of data. Let's run it. And so this is the first 5 rows of your data that you have printed out here. 1, 2, 3, 4, 5. Now if you wanted more, you could say give me the first 6 rows, and it's going to give you the first 6 rows. We have the first 6 rows of our data. And if we look, we have the column names as well. Of course, if you have the heads, you most likely have a function called the tail. And sure enough, that's the case. What the tail function does is it shows us the bottom rows. Sometimes you want to see the top rows, you use the head. When you want to see the bottom rows, you use the tail. What if you just want to see a random sample? What are you going to do? So to see the random sample, we're going to just reuse this and put a word called sample. We'll provide, let's say, random 2 rows of data. And if you run this, you see here that it gives us 2 random rows of data. We can run it again and it's going to give us another 2 random rows. And we see this is different as well. Let's do it one more time. And we see it gives us something different. So these are the ways you can read in your data, check the shape of your data, check the column names in your data, look at the head and tail of your data, and the data. Thank you for watching, and I'll see you in another video. Welcome to this section. We're going to discuss Plotly and how you can use Plotly to create data visualizations. Data visualization is a very important part of this course, and so we're going to have a quick crash course on how you can use Plotly to create different types of visuals. By the end of this section, you would have learned how to create all types of charts: histograms, bar charts, scatter plots, line charts, and several other charts. This presentation covers the basics of Plotly and what you can do with it. Plotly is one of the most commonly used visualization libraries in Python. is built based on JavaScript, and so it has a lot of features that makes it very easy to integrate with web applications and dashboards. Plotly has the ability to create all types of visuals, from the basic ones. In this section, we're actually going to cover quite a bit of them. One of the key things that differentiates Plotly from other libraries like Seaborn and Matplotlib is the fact that it is interactive. So every chat you make from Plotly is an interactive chat. So you can move your mouse over it and you see the points, you see different kinds of feedback from your visuals. And this makes it a much more easy to use when you're carrying out extra data analysis, or when you're embedding your chats in a dashboard. So like I've said previously, Plotly allows you to make all types of chats you can think about, and you're also able to create more advanced chats. Some of the images you'd see in this slide were created using Plotly. Now with Plotly, you have, which is kind of like the light version of Plotly, but then you have the main Plotly where you're able to create pretty much any visual as long as you are comfortable using the Plotly API. You can add different chats on top of each other and make like a custom visual. Most of the time, for 90% of the use cases, you're most likely going to be using the Express API within Plotly, which makes it very easy to create some of the most common chats in a very, very simple and easy API. Visuals you create with Plotly have several interactivity embedded into them. So you can zoom into your chats, you can hover around different points in your chats, and you can actually pan and move your chat around with just your mouse. That makes the chats you create with Plotly very interactive by default. In this short presentation, we've talked about Plotly and why it's good to use Plotly for data visualization needs. If you've never used Plotly before, you've never even heard of it, don't worry about it. In this section, I'm going to walk you through the basics of how to make the most common Plotly, because that forms the foundation as we go into the more advanced parts of this course where we actually build dashboards combining powers of Plotly, Pandas, and Streamlit together. Thank you, and I'll see you in the videos in this section. Welcome. In this video, I'm going to show you what Plotly can do. So if you visit plotly.com, this is mostly, of course, it depends on when you visit this site. Plotly has much more than just the visuals. They have several tools like Plotly Dash that you can use to create dashboards. This course is focused on creating visuals, and we're going to use Plotly as one of the libraries. So if we come here under Docs, Plotly has libraries for R, it has libraries for Julia, JavaScript, MATLAB, so many other languages out there. But we're only focused on Plotly Python, so we're just going to click this. And this just shows you different types of chats that you can create using Plotly. There's several of them here. It's quite an exhaustive list. This is what we're going to be using in this course. We're going to learn how to make interactive chats like this. So if we check one of the examples, let's say we look at the scatter plots, or we could look at the bubble chart. The key Plotly from other libraries is the fact that it is interactive by default, and you can do a whole lot of things. You can zoom in, you can zoom out. So if you do this, you just pull your mouse, you can actually zoom into the different points. And these are just some of the examples of the things that make Plotly really, really cool. So yeah, this is a very simple introduction to Plotly in Python. I'm excited to show you all the cool stuff we can build with this library. Thank you for watching, and I'll see you in another video. We're going to learn about scatter plots in this video. I've imported Pandas and Plotly Express as PD and as PX. To learn about scatter plots, we're going to use the iris dataset. I have it opened up here. We have 4 numeric columns, and then we have the species column that just shows the type of flower. First step is to always get your data into a Pandas data frame object. We'll just do this, and we'll call the name of what it is, the file name, iris.csv. If we run this, it should run without any issues. Okay, we see that the import worked. We could also just look at the columns that we have here. To create our chart, we'll just give it a variable name, we'll call on px. We'll use the scatter module. Then you need to supply the data frame. It's df in this case. You specify what you want on your x-axis. You specify what you want, and you give it a title. We can go here. Let's say we want to create a plot of sepal length. Come here. We'll just pass this in as a string. Say sepal length, one sepal length on the x-axis. And let's say we want the petal length on the y-axis. We'll come here, pass this as a string. As long as you've passed in the data frame object, you can pass all of this as a string and it will be fine. Next, we give it a title. We'll say, you should always give it something descriptive. At this point, we've defined a very basic scatter plots. There are other things we can specify, which we will express. Next thing you need to do is to call the show method on the plotly graph object, and this should be fine. So if you run this, we should see a visual come up soon. There you go. This is our visual. We see what we have on our x-axis, we see what we have on our y-axis, and we have the title. This is fine for a very basic scatter plot. There are other things we can specify for a scatter plot. Let's go back into the code and do that. We can specify the color. In the case of these data sets, we know that we have this categorical variable called species. We can just copy that. I would set it up in a way where each point is colored by the value here. And if we rerun this, we'll see a different outcome. Let's go do that. I can see that this is the same visual, except this time around, we've colored it by the species, the categorical columns. This is code. What if you're interested in increasing the size of each point based on the value of a numeric column? You can also do that. Let me show you how. You come here and supply the size parameter. Let's say we want the size of each point to be represented by the sepal width. All we have to do is pass this in, and we can run this as well. I would see the outcome when we go there. You see that the visual changes. Now every point is not the same. This point is bigger than this one, and this point is definitely bigger than this other green point, because the size of each point is represented by the size parameter in Plotly Express. What we can do next is we can go ahead and just supply something. This might just be all you need to do. This is totally fine. But if you wanted to do much more, if you are interested, you can definitely pass in more parameters. One that I'd like to just show you is what you call the facets in Plotly Express. What this just does is it breaks down the visual based on a categorical variable. In this case, let's use species. So you can break down the visual this way. Pass this in. Let's run it and see what it does. I'd say that we have a very effective visual in this case. We'd see it's separated by the species and it's also colored. If you don't want to do it by do the same thing, but instead of doing it for the columns, it's going to do it for the different rows. Let's just change this to row, and we can run this. I'd see the outcome. You'd see that we have the same visual, scatter plots, but this time each species is on different rows. Let's go back to the code. This is how you can go about defining a scatter plot using Plotly Express. At the bare minimum, you need to pass in the data frame. You need to pass in what's your X, you need to pass in your Y, and it's always a good practice to have a title. Depending on what you have in your data, you could also supply the color, the size, or if you want to be faceted on the rows or on the columns. Thank you for watching, and I'll see you in another video. In this video, we're going to learn how to create histograms using Plotly Express. We've passed in our data frame, which is in this case the iris data sets, which you have here. Assuming we want to get the distribution of, say, sepal lengths, this is how we're going to go about it. We'll come here, create a variable name plot, say px.histogram, pass in a data frame, in this case df. With histograms, when you want to do the most basic form of it, you just need to specify either as your X or your Y, depending on what orientation you want to have, the column name where you want the distribution to be created from. In this case, we do it this way. Of course, this has to be a string. Let's pass this as a string. And you can pass in a title. Let's give it a title, distribution. So this is our Plotly graph object. We're just going to call it here. And there you have it. We have this here. This This is our histogram. Now you see we have 1, 2, 3, 4, 5, 6, 7, 8. About 8 bins. This is done automatically. You might want to make a change to it. So let's go here and adjust the bin size. Let's say we want 15 bins. We want it to be spread out a little bit more. Let's run this. We see that it attempts to spread it out. These are the kind of things you can pass in here. Let's say we want just... This doesn't look as good, of course. Let's go back here and change this to, let's say, 5. And we see that this is also different. Normally, whenever I make histograms, I rarely provide this parameter. I use the default value that comes with Plotly Express. Sometimes I might play around with it a little bit just so I can see what it looks like whenever it's changed. But with this, you're able to create a histogram in Plotly Express. You can also add the color parameter whenever you're making an histogram. So we can say species. Let's go back and make sure we're spelling that correctly. Species. If we run this, we'll see what we get. You see that it splits it this way. Let's go back and use the default value here. You can use 8. With a histogram, you can go further and specify the bar mode. Just essentially, how do you want, if you're going to color it, how do you want the different colors to be together? Do you want them to be grouped together? Do you want them to be side by side? This is the parameter you specify for this. Okay, you see what it looks like when you specify the grouped parameter. We could also set this up as overlay, different options. And we see that it has a different look as well. At this point, you see that for a histogram, you can specify the data frame, whether you along the x-axis or the y-axis, and give it a title. All of this, you don't necessarily have to specify them for a histogram to get a functioning histogram. But if you wanted to, this is how you can do it. Thank you for watching, and I'll see you in another video. In this video, we're going to learn how to create box plots and violin plots using Plotly Express. We've passed in our dataset as a data frame. Now we just need to call on the Plotly Express library and call on the box. So let's start with the box plots first. You'd say plot is px.box. You pass in the data frame, df. Then you specify, at the bare minimum, you need to specify your y-axis and give it a title for box plots. On our x, we want the species. Of course, you could swap them and see which one you feel much connected to. I think this is fine. This is our iris data set. Let's say we're seeing what the distribution of sepal will be. Just copy that, put it in here, give it a title, pass in our title. To have a very basic box plot, this is all you need to do. Pass in your data frame, pass in what you want on your x, your y, and give it a title. Then you just call on the show method, and you have this. So let's come here, run it, and see what we get. So we have our basic box plots here. We see this. You can see that clearly the 3 species are very different when you look at the sepal width. You can see the median line here is different from the median line here, is different from the median line here. That's great. So this is a very basic box plot. What happens if we swap x and y? Let's go check it out. Let's change this to x. It's going to cry a little bit because, you know, you've passed x previously. Let's do this and run. So you see the same thing. We have this here, except that is oriented a different way. We have the species on the y-axis and the numeric variable on the x-axis. This is great. This is totally fine. I prefer the other one, but you know, depending on how you're trying to make your visual, this into the code. So this is how you make a basic box plot. What if you wanted to add a color? You could color it by the species, and you have this. So if we run it, let's change this orientation as well. I actually prefer the X and Y like this. So let's just change it. Let's run this again. And you see this very different look from the previous one, because in this case, we have every single species colored differently. That's totally fine. It all depends on what you're trying to do. So this is how you can make a basic box plot using Plotly Express. What if you don't want to make a box plot? What if you want to make, say, violin plots? They're actually very similar. They can be used for literally the same thing. All you have to do is, instead of box, you change it to violin. For me personally, I have a preference for box plots. So I'm very rarely do I use violin plots. But if you want to, you can. Let's do this. We can comment this out so that we don't have two things showing up at the same time. We'll change this to violin. And you see the orientation here, the indentation is not correct. Let's fix that. Let's do this. So we supply literally the same thing, and we can run this and see. Whenever you can use a box plot, you can also use a violin plot. Taste and what your audience is familiar with. So this is it with the box plot. You can see very similar in that it shows the same information, but some people will like it. One additional thing you can supply here is you can choose to show the box. Yeah, you can say box is true. And if we run this, we'll see what the visual would look like. Let's come here. You see that each of the violin charts have a box plot in there, right? So you see this. So you can think of a violin chart as a combination of a box plot, and the side represents a histogram. So let's go change the orientations just so you can see what I'm talking about. Let's go back here. Change this to Y, and we can change this to X. Run this. The information you have here is essentially the distribution. When you look at it along the curve, it is the histogram mirrored across the center line, and then you include the box plot in there. At the end of the day, you could use a box plot, you could use a violin plot. It all depends on using with your audience and what your audience also is familiar with. Let's change this to violin. And yeah, this is how you make a very parameters you can specify, but whenever you want to make a violin plot, this is definitely how you're going to do it. Thank you, and I'll see you in another video. We're going to learn about pie charts and how you can create pie charts using Plotly Express. We will be using the tips dataset. We see here that we have the total bill, sex, smoker, day, time, size. Let's say we're interested in seeing what the gender, so male, female, we want to see who gives the most tip. You want to use pie charts when you have different discrete values that you want to see but when you start having like 6 different pieces in your pie, it doesn't look good, right? You might as well just use something else like a bar chart. Male and female. For this demonstration, we're just going to look at how does the total tip vary across the gender? Who gives more tip, essentially, when we look at the total? For that, we're just going to come here and say plot is px. This time around, we'll call pi. We're passing our data frame, in this case, df. For a pie chart, you need to specify the values, the names, and give it a title at the bare minimum. So let's say values. In this case, what values mean is just what is that numeric quantity that you want to break down. In this case, we want to see how the tip is spread. So the tip is the values. Then you need to pass in the names. And of course, good practice, always pass in a title. Pass in a title and just say pie chart. It's going to work. So let's run this. This plot object is created. We now need to show it. So let's call the show method. Okay, if we do this, let's run it, run. And there you have it. We see that the male gender tends to give, in total, larger tip. And we can see the value as compared to the female gender. So this is a use case for pie charts. Now, this is what pie chart is good for. Let me show you what a bad pie chart will look like. If we were to change this from sex to day, then you'd see that it would not be as good looking as that. So let's change this to day. This is how you do not want to use your pie chart. Okay. And there you have it. You see, it just looks weird because the challenge with this is how are you going to be able to distinguish between this and this visually without having to look at the number? Of course, the number is there. That's totally fine. And I'm happy the number is there. This is not a good use case for a pie chart because assuming the number wasn't there, it will be difficult to tell the orange region from the blue region. You might want to pass in another parameter. You know when you have pie charts that have a hole in the middle and then it becomes a donut chart? This is how you can specify a donut chart. So if we run this, see that now there's this cutout region in the circle. By specifying 0.5, we're saying, okay, give us a hole that is half the size of the radius. That has half the radius of this smaller circle is half the radius of the bigger circle. Let's change this to 0.9 and you'd see what that looks like. Change this to 0.9 and see it now looks more like a steering wheel. Some people like to have holes in their pie charts. Most people don't. You know, it all depends on you and your audience and what you want. But for demonstration purpose, we could just do this. Let's use a slight little hole, just 0.3. Nothing wrong with that. Okay, so we have this hole. Now, pie charts together. You could do a facet column. For example, in this case, we have several columns that we could have used for the pie chart, but we couldn't do all of them at once. So we focused on just the sex. But what if we wanted to break down the tip across sex and whether that person is a smoker or not? You could add a facet column or facet row, doesn't matter. I like to use facet column. I'm passing the value smoker and you run this and see what it's going to look like. You'd see that it drills into the pie chart a little further. In this case, it breaks it down by smoker versus non-smoker. Because if we compare it to this, the previous pie charts here was just broken down by the gender alone. Now this is broken down by the gender still, but we split it further across smoker versus non-smoker. You could decide to stack this using facet row instead, but I prefer facet column because for most displays, you have enough space horizontally as compared to vertically. Now you could definitely do this with your pie charts. Let's go back into the code. And there you have it. Whenever you want to make a pie chart, the key things you need to provide your data frame, the values, that is, what is the numeric column you're interested in breaking down? What do you want us to break it down by? So essentially, what are the names of the sectors of this pie chart going to be? You could decide to break it by the facet column. You can decide to pass in a whole, but you should always give a title. And there you have it. This is how you make pie charts using Plotly Express. Thank you. We're going to learn how to create bar charts. Let's look at what our data looks like. We've imported all the necessary libraries. We could do a print here. df.head. Let's run this. Now this is what we have for our data frame. And of course, we can show it here as well. With a bar chart, we might be interested in seeing what the average petal width is across the different species. So we want each bar in the bar chart to represent the average petal width, or you could do the median, or with bar charts, you can do the count. It doesn't really matter. You decide what the size of each bar would represent. In our case, we want it to represent the average petal width. The best way I've seen to get the best outcome is to aggregate your data frame first and then pass the already aggregated data frame to a bar chart. Let me show you what I mean by that. For me to get this average, I would need to do a pandas operation group by, a very simple pandas operation. And I'm interested in performing the group by operation based on the value in the species column. If we run this, let's give it a variable name. I'll show you what this outcome looks like. For me, whenever I do a bar chart, I always aggregate the value to be sure that what I'm going to show in the bar chart is exactly what I expected to show. Because sometimes, depending on how you specify your bar charts, you might end up with the bars representing something totally different from what you expected. And we definitely don't want that. So I always take like an intermediate step to process the data before creating the visual. In this case, I can show you what this looks like if we do a print of df1. Let me show you what that looks like. So let's run this. I see here we have species, Setosa, Versicolor, Virginica, and we have these values here. One important thing that you always end up doing is resetting the index whenever you work with group by statements. What does resetting index mean? Essentially, what it just is it helps to flatten, think of it like it just flattens out the structure. You see how this is kind of indented that way? Because it serves as the label for each rows. You could change this label to become one of the columns, and that's what the reset index does. So let's put a period instead of a comma. Yep. Okay, now we can run this and I'll show you. Just watch the change that's going to happen here once we run this. So let's run this. I see that it's been flattened. Now this species is accessible across different points here. That's good. At this point, we can go ahead and make our charts. Let's say we want this to be on our x-axis and we want petal width on our y-axis. We can definitely just do that. So to do that, we'll go get a variable name for the plot. We'll call on the bar, pass in our data frame, df1 in this case, using what has already been aggregated, species. And I want on my y-axis, I want the petal width. Let me just type that, petal width. Of course, you want to give it a title. So let's give it a title, something descriptive, bar chart showing petal width species. If we call on this plot.show, we should see something. Okay, let's go do this. I see that the average petal width varies. Setosa has a lower average compared to Polar and then to this one, Virginica. Very easy to see the information this way. So that's pretty much it when it comes to bar charts. They're actually very simple, very useful. For you to always get the right outcome that you want, you definitely want to carry out the aggregation first. So do this calculation, whatever it is you're interested in. In this case, we're interested in the mean. You might be interested in the median. You might be interested in the count, whatever it is. Do it first and then pass it into a very simple bar chart. And there you have it. This is how you make a simple bar chart in Plotly Express. Thank you for watching. A scatter map box is a very simple chart in Plotly Express that shows different points across a geographical map. Now, this can be useful if you have a physical parameter or a numeric parameter that changes across geographical regions. So if you have information about, let's say, the country and how maybe the temperature across different country changes, then you could use like scatter map box to get that information. If you have the latitude and longitude coordinates, you could also use this. So I'm just going to show you with this data set. We have this data set where we have information on city, state, population, latitude, and longitude. So those are the coordinates of the different cities, the location, and then we have population. We can use the scatter map box to show this population at the different points specified here. And I'll show you just how to do that. Let's first read this data in. So we're going to use this data and we're going to do this. Get a variable name for our Plotly graph object. And we'll specify scatter map box. We'll pass in our data frame. Depending on the information you have for your geographical region, latitude. So for the latitude, we'll pass in lat because that's what it's called in the data set here, lat. And we go here, pass in our longitude if you have it, and we do. So we'll pass this in. Next, you need to provide the size parameter. So you're essentially saying at the different geographical points, what should determine the size of each point? That's the parameter you're going to pass in here. And in this case, we're going to make cities that have a big population or a larger population to have a larger points than those that don't. So the size parameter is population in this case. We'll do this. Let's just arrange this so it just looks much better. And we give it a title. We'll say population across different cities. Okay, we'll call the show method again. One additional thing you need to specify is the style you want to use to show the map. It's called map box style. Now there are several options. So we'll do this here, pass in OpenStreetMap. Let's run this and see what we get. Now this is what we get when we create the scatter map box. Although we didn't see anything there because we need to specify the zoom level. So how much do you want to zoom? Let's try different numeric numbers here and see what we get. Let's run it. Okay, you can start to see that we do have different points. You see there are different points here. We can adjust the zoom level as well to see what works for what we want to do. Let's change this to, say, a 7. See what we get. So 7 goes in too much. Let's change it to, let's say, 2. So you keep changing this zoom parameter till you get that captures the map the proper way you want it to be captured. Okay, so we can see that across the entire continental US, the population size is much bigger than at this point. We have to try a different value, let's say 2.5, and see what we get. Okay, see that. Let's change this to 3. Okay, see that this is a fine level. Let's say maybe 3.5 or 4. Let's say 3.5. So this is the idea. You want to keep adjusting this level of zoom till you get to a point where you're satisfied with the outcome. I think this is fine. We could try one more value, let's say 4, and see how we can fill the entire space. Let's say this will be a 4. Okay, yeah, this is much better. This shows the continental US and the different points represent the size of the population. You can also supply what name you want whenever you hover over the different points. If we come here, we say we want, let's say, the city. We could definitely do that. We'll just get this value, put this here for the city. Let's run this again. So whenever I go over each point, it shows me the name of the city. So if I come here, that's San Antonio. This is Houston, Cedar Park. Let's see what we can get if we adjust the zoom level again. So let's change this to 4.5. Okay, I think this is perfect because we can capture majority of the map and it's at a good enough level of detail. And there you have it. This is how you can create a scatter map box chart in Plotly Express. Essentially a chart that shows different geographical points and how values vary across those points. So essentially we scatter plot points, but instead of just being on a plain sheet of plotting area, it's overlaid over a map. That's what a scatter map box does. Let's go into the... You'd see here we have our library, we have our data frame. We called the scatter map box. We passed in our data frame, latitude, longitude. We passed in what parameter should dictate the size of each point by passing the size parameter. We gave it a title, and we did spend quite a bit of time adjusting this zoom level because that is likely something you're going to do when you're working with this kind of visuals. You're going to adjust it depending on whether you're trying to zoom into a state, street. You use this zoom parameter to change that. And then you need to also specify what map box style do you want. There are several options. This is one of the more reliable ones because it's free and you can always use it for a lot of your charts in Plotly Express. And there you have it. We've learned how to create scatter map box charts. Thank you for watching, and I'll see you in another video. In this video, we're going to learn about templates in Plotly. A template is a way where you can change the overall look and feel of your Plotly graphs. For this, we're going to use scatterplot as an example. But of course, every other chart in Plotly actually has the template parameter that can be set up. There are several options we can use. So I'm going to show you all the Plotly theme options that exist. We can put this here as a Python list. I'm going to go through each of these one by one and see what we find. So we're going to start with this basic example where we're not using any template, we're using the default values. We can run it and see what it looks like. So the default Plotly template looks like this. Uses the blue, the orange, the green. The graph area is kind of gray and every other thing is white. We can change that by specifying the template parameter. So we'll say temp and let's plot too. So you can just get this, copy it. The reason this is important is sometimes you might want your visual to look different from what every other person's visual looks like. Because most people just use the default Plotly template and everyone's stuff just looks generic. But here we're going to go make some changes so that whenever you make a visual, it does stand out. We're going to see what this template looks like. So let's put a title and just say ggplot template. Let's run this and see how this looks different from the other ones. Shade of colors used is different. Let's see what this second option looks like when we change it as well. So we can change it to Seaborn. Let's change to Seaborn. So we change this to Seaborn. Let's go run this. You notice that there's a difference as well. You still have this gray area. We still use blue, orange, and green as the defaults. Something else. Let's say simple white. White. You see, we started from this, and this. You can see that here, everywhere is white. There are no grid lines except on the exact axis, nothing in between. Let's go look at this as well. Let's change this to Plotly. Say Plotly. Let's run this. See, it's plain here. Change this to have like a bluish gray look. It's also different from this and definitely different from this. We can try Plotly white. So Plotly or white. Let's run this as well and see what we get. This is similar to this white, except that it has the major grid lines. So you have the grid lines on X and Y. So this and this are very similar. Here is completely plain, but here you have your grid lines. Let's look at Plotly dark. So I'm sure you can already assume how this is going to look. Say Plotly dark. Let's run it. I see that the entire graph area that used to be white or gray or grayish blue is completely dark, everything. This could be useful if you're going to use like a dark theme for your Plotly. If you need a dark theme maybe in your document or you need a dark theme in your dashboard, this could totally look at this option, presentation, see how this is different. We can run this. See, this is similar to this in a way, but you can see some slight differences. If you check between both, you see differences in the lines and the differences in the color of the plot area. So that's also a difference. Then we can look at X grid off, essentially just saying switch off the X grids. Okay, let's put this here and see what the outcome is. You notice there's nothing coming from the X-axis, everything's coming from the Y-axis because we said X grid off. So we can just change this to Y grid off. And you see it's the same, except that this time nothing comes from the Y-axis, everything comes from the X-axis. You can change this to grid on. Let's see what that looks like. Okay, this is different too. And there you have it. In this, we've been able to look at different template options for your Plotly graphs. It's useful because you might want to give your charts a different look from the default. And that's what we've successfully learned here. I'll see you in another video where we learn some cool stuff. Thank you. We're going to talk about sets in Python. A set is a very unique data structure in Python. You can think of a set as a collection of things, but with some very special rules. One of the key rules of a set is that whatever you have in a set must be unique. If you look at the basket on the right, we see that there's an orange, there's an apple, there's a strawberry. Assuming the basket is a set, you can't add another orange in there, you can't add another strawberry, but you can add a completely different fruit that is not currently in the basket. That is one of the unique aspects of a set that sets it that data structure. If you look at the baskets, we don't really care about the arrangement in the basket. It's unordered. We don't care how it is. We don't care if we put the orange first or the strawberry first. All we know is that once we look at the basket, we have an orange, we have a strawberry, and we have an apple. And because programming in general is all about copying what exists in the real world and finding a way to represent it in the computer, that is why we have the set data structure here in Python. Some of you might be familiar with the Venn diagram, but if you're not, don't worry about it. When you look at the group of vegetables and then fruits and vegetables, we have tomato that is somewhere in the middle. So the area here that you have that is kind of like lighter yellow, you're going to have a tomato right there. What that shows us is the set data structure can be used for this kind of computation. And so there are some operations that you can carry out on a set that can represent what happens in a Venn diagram. And that's also a very unique use case of the sets in Python. There are different ways you can create a set. You can use curly braces. We know that in a set, you cannot have duplicates. And we know that the elements in a set can be of different types. So in one set, you can have numbers, you can have strings, and every other type of data that is out there. As long as it's not duplicated, you're good. How do you add elements to a set? You can add it using the add function or the add method. And that's a very popular method you are likely to use whenever you're working with a set. Now, there are three ways you can remove elements from a set. You can use the method called remove, you can use discard, you can use pop. These are three ways. They're all different in how they react, and we're going to see this in the coding section. The in operator can be used to check if an element belongs in a set. For example, if we wanted to know if there's apple in the set, we can use the in operator to check if the apple exists. We can also use the not in operator to check if an item does not exist in our set. There are different kinds of mathematical operations that can be on a set. So you have the union. The union essentially just combines multiple sets together. You have the intersection, where it just finds elements that are common to both. And you can also look at the difference, which is when you have two sets, how are they different from each other? But don't worry about all this. We're going to see this in the coding section. I just wanted to make sure that you have seen it once at least before we start writing the code for it. Some of the common ways sets are used is for duplicate removal. Let's assume you have a list of numbers and you have multiple duplicates in your list. Once you convert that list to a set, what you're going to have is just a unique representation. That's it. Every single duplicate is going to be removed. And we are able to do this because we are leveraging the key feature of a set, which is it does not allow multiple entries of the same item in the set. In this lecture, we talked about the set data structure in Python and what it can be used for. The key feature of a set is you can use it to remove duplicates from other sequence data structures, and that makes it very powerful and very versatile. In the following video, we're going to have a code along section where I'm going to walk you through how you can play around with different sets that you might have. Thank you for watching, and I'll see you in the next video. Hello, so we're going to learn about sets in Python. A set is another important data structure in Python used for doing very amazing stuff. A set does not allow duplicate elements. To define a set, you use the curly brackets. So let's just say my set is this. So this is the same brackets you use to define a dictionary. The only difference is in this case, you don't have key value pairs. Let's create a set of numbers. If we print this set, I want to show you what's going to come out. Now you notice, even though we have multiple elements, multiple duplicates for 2 and multiple duplicates for 5, this is all that is printed, 1, 2, and 5. That's because a set does not allow duplicate entries. This can be useful for several use cases. Let me show you another example where we convert a list to a set. What you have here is a list. We called it num list, and I decided to add a text in there because the list allows you to do that. Now if you use the set keyword and you pass the num list, the list within the parentheses, it's going to change this num list into a set. We have another set. It looks at all these multiple duplicates for the number 2, and it picks just one of it. Returns 87, returns 9, and returns apples. This is what the set can do. There's another way you can create an empty set, and if you check the type, you see that it's a set. So in this video, we've learned the basics of sets in Python. We've learned how to define them. We've learned the basics of what it's used for. In future videos, we'll learn some more cool stuff. Thank you for watching, and I'll see you in another video. In the previous video, we talked about how sets are unordered. What that means is if we try to index a set, it's not going to work. So for example, here we have this set numbers. We can just copy this again. Let's copy it here again. So we see this is our set. Colon index 0, index 1, whatever it is to get the different positions. Now with a set, that's not possible because it's unordered. Let me show you what happens if you try to do that with a set. We could just copy this. Now already you see PyCharm is trying to tell us, hey, class set has no defined get item. So the square operator cannot be used on this instance. So we already know there's going to be an error very soon. We see, okay, trace back. Okay, there's an error and it showed us exactly where the error is happening. This was the command that caused the error. And it says type error set, meaning you can't use the square brackets to slice it or anything like that. So we know slicing is not possible in a set. If slicing is not possible, how can you access the elements in a set? Well, you could do it in different ways. You could check for membership using the in operator. That's one way. So let me comment this out first so we don't keep seeing this red error page here. And we could also loop through items in a set. I could show you that. So let's say for set element in numbers print. So this is the entire set and these are the elements in the set. So this is how you can access elements in a set. Now, of course, you can always change the set back to a list and, access it directly that way. Another thing you could do is you could check for membership. Let's check for membership using the in operator. So we could easily check, okay, do we have apples in what we call in numbers? We can print this expression and seeing that we have apples over here, it should give us true when we do this. So let's run it and we see true. And yeah, there you have it. In this video, we've learned how you could access elements in a set. A set is built for a different use case. So if you need to be accessing elements in a set, then you might want to use a different data structure. But if you want to be able to remove duplicates, then yes, a set is most likely the data structure to use. Thank you for watching, and I'll see you in another video. In this video, we're going to go over how you can add or remove elements from a set. Let's say I have a set of my favorite fruits. Call it my fruits. This makes sense using a set because we know you are unlikely to want to repeat names of fruits that are already your favorites, right? We have this, let's say mango, strawberries, orange. We can print it out and print the type. So we see that it's a type of set. Now, if I want to add to it, I can just use the add method. All I have to do is just say my fruits. Let's say I add tomatoes. So if we print this, we'll see now that we have tomatoes, strawberries, mangoes, and orange. I know when we first started talking about sets, I talked about how a set is unordered. And this is just a good example of how a set is unordered. You'd see here that each time I run this, the arrangement changes. Right now it starts with mango, ends with tomatoes, with orange and strawberries in the middle. Let me run this. And you see now it starts with tomatoes, oranges at the end, it changes. So this just lets you know that a set is very much unlike a list or a tuple in that there is no specific order to it. I've shown you how to add an element to a set. How then can we go about removing elements from a set? There are several ways we can remove elements from a set. The first one is using the remove method. The remove method would raise an error if the element does not exist. So what I've done is we have this my fruits set. I added banana into the initial definition. And I previously added the tomatoes using the add method. Leave this out for now. When you attempt to remove tangerine, you run into some problems. Let me print this first, show you that it works for the case of bananas. Let me run this again. You'd see here that this is what we have. We have bananas here. And after we carry out this operation, we print it out again and banana becomes missing. When you attempt to remove tangerine, we get into an error. And the error is simple. The error says key error tangerine and it's showing us the line here. It's essentially telling us, okay, the problem is actually from this line. And why is it an error? It's a type of key error because tangerine is missing. And that's the case because we attempt to use the remove method on a set. So let's uncomment this out, run this. You'll see that even though we don't have tangerine anywhere in this set, it doesn't give us an error. Now, if we attempt to remove something that exists, you see that discard works. Let me find something there. Let's say orange. So we can discard orange and we can print my fruits again. So I'll show you the difference. Let's print this here. Let's run it. You see orange is missing here. When we use the discard, it did this. It didn't do this, but it just kept quiet about it because there is no tangerine in the set. That is totally fine. And when we print this out, we're able to just print out the set in its current form. So that's why you might want to use discard much more than you'd use remove. Because if that element does not exist, you're going to get an error. But discard can handle that scenario in a gracious way. Now let's look at the other methods. Pop, for example. The pop method helps to remove an element. The only challenge we have with the pop method is it just removes an element at random. You see? Because the set is unordered. In this case, we see that we start with 1 to 5. And after I use the pop method, we're able to return what was removed in this case, which is 1. So we have 2, 3, 4, 5. Great. What if you just want to clear everything in your set? That's where you use the clear method. So the clear method removes everything in the random set. So the random set is 1 to 5 here. Now, if you print a random set after calling the clear method on it, we're going to see that it becomes an empty set. And that's what we have. We get an empty set because it clears everything out. In this video, we've learned quite a bit. We've learned how to add elements to a set using the add method. We've learned several ways you can remove elements using the remove method, the discard method, the pop, and the clear method. Thank you for watching, and I'll see you in other videos. In this video, we're going to talk about some of the set operations. So we have two sets here, set A and set B. We see that we have 1, 2, 3 in set A and 3, 4, 5 in set B. Let me comment every other thing out so we can focus one at a time. Now, if we look at this, we see that the element 3 is common to both of them. If we look at the union of everything, we're going to get 1, 2, 3, 4, 5. So let's look at union operator. What it does is it combines two sets together. So it looks for everything in set 1 and set 2 combined together without any form of repetition. So let's print this outcome and see what it looks like. We can expand this, and this is what we have. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Sometimes you are interested in looking at the intersection between two sets. In this case, intersection just means what is common to both of them. We see here that the element 3 is common to both of them, like this. And so when we run this code, we should see 3 being outputted. You can use this operator or you use the intersection operator. Either of them works perfectly fine. Let's run this outcome and see what we get. You'd see that it returns a set with a single element 3. Sometimes you might want to look at the difference between two sets. You look at this set has 1, 2, and 3. This has 3, 4, and 5. So you might be interested in seeing the elements in A that are not in B. So if we look at it, we see that 1 and 2 are in A, but they are not in B. The difference of A minus B is going to be 1 and 2. Let's print this result and see what we get. 1 and 2. Now, what if we are interested? Let's paste this, and this is B, difference A. That's what we get. So what is in B that is not in A? Well, 4 and 5. Let's get the output from that. 4 and 5. The next thing we can look at is the symmetric difference. What the symmetric difference does is it looks at both sets, A and B. Of course, you can call it using this command or this keyword symmetric difference. What it does is very simple. It looks at both sets and lets you know what exists in either set but not in both. In this example, we know 3 exists in both of them. So the symmetric difference will be 1, 2, 4, 5 because they don't exist in both of them. Let's run it and see. Let's run it. And we see that the symmetric difference is 1, 2, 4, and 5. And these are just some of the operations you can do with a set. Thank you for watching, and I'll see you in another video. Welcome In this video, we're going to talk about the data structure called tuples in Python. Tuples are another interesting data structure, very similar to lists. You can think of it as a way of organizing data together in a type of box. What makes tuples different from a list is that with a tuple, you can't change stuff. Once you put a data in a tuple, you can't change it. It's fixed. And so that's why you can think of a tuple kind of like it's a treasure chest of some sort. And that's a key difference between a tuple and a list. Whenever you want to create a tuple, it's very simple. We have these 3 examples. All you just need is to create a variable name with your equal sign, assign the variable name to the items in the bracket, and you've created a tuple. Whereas whenever you create to use a square bracket, the brackets you have here. For you to access the items in a tuple, you can use the indexing that starts from 0 all the way to the end of the tuple. So if you want to get the first item, you use the 0 index to locate the first item in the tuple. If you want to get the next one, you use the 1 number, and then you'll be able to access what's hidden within the tuple. The 2 core methods of a tuple are count and you have the index. The tuple we have here has items 1, 2, and 3. Python allows you to carry out something called tuple unpacking, where with the expression in position 2 there, you can see ABC is equals to 1 data structure. When we print out what A, B, and C are, you can see that they just get the items in the tuple. Now, this operation that you just see here in the middle is what you call tuple unpacking, and it's a very useful trick when it comes to working with tuples in Python. Let's assume you have this beautiful treasure box on the right, and it's your job to go through every single coin in that box to look at it, check if the coin is authentic, check what the value of the coin is. For that kind of operation, you need an efficient every single coin in the treasure box. As with every other data structure in Python, there is a way to loop through tuples as well. Whenever you're going to be able to go inspect the item one by one, and don't worry about it. In the code along section, I'm actually going to show you how you can achieve this using your for loop with a tuple. What are the typical use cases when we need a tuple? The core trait of a tuple being unchangeable once it's been created makes it such that it can be very efficient. If you have the chance to pick between a tuple and a list, there's a good chance that the tuple is going to be much more efficient in storing the data as compared to a list. You use a tuple for data security because the items in the tuple cannot be modified after they've been created. Use cases where data security is important, where code efficiency is important, those are the kind of times when you're likely to use tuple as your data structure of choice. Thank you for watching this video, and I'll see you in the code along section. Hello, in this video we're going to learn about tuples. I'm going to create a variable here. Just call it numbers. And with this variable, I'm going to create just a simple tuple here. We have this tuple here. We can use the type function in Python to show that it is indeed a tuple. So we have, and it shows you here that this is a type of tuple. Tuple is kind of similar to lists. If you look at it, you see that with lists, we use the square bracket or what you call the parentheses. Tuples are immutable. You can't just change stuff around randomly. And I'll show you what that is in this video. Let's keep going. You'd see that we have some extra tuples here. So this is what we had previously. We know this is a tuple. We have tuples here of strings, different fruits that I love to eat. So apple, banana, cherry. I can print them, and you see here that we have a tuple with mixed types. So you have an integer, you have a float, and you have a string. Okay, let's run this and just look at what all of these looks like. We're able to print out the contents of a tuple. That's really good. We're going to move on to some other functionalities of a tuple. Now, sometimes you might want to create a tuple from a list. So let's look at my favorite cities again. Let's just create a basic list here. Now, if we print the type of this, we'll see that it is a list. So let's do that. Let's run this, and it shows it's a type of list. Now, if I want to change it to a tuple, something I can do, which is very easy. Let me copy all of these, save us some time from watching me type, and just add tuple. Okay, tuple. And for this, I'm just going to wrap this in the tuple command. It's a built-in command in Python. Now, if we run this, we're going to see something different. So let's run it. You see that something happened. We've started out with this list, favorite cities, just some 3 random cities that I really like. We printed the type, we see that it's a list. That's what we see over here. Next, we use the tuple command to change this list into a tuple. And when we check the type, we see it is now a tuple. We've shown you that you can move from a list to a tuple. I want to demonstrate how both of them are different. Let me show how they're similar first, right? So let's do this. Let's just print the length of both of them. We could actually do it here. Let's say fave cities, good. And let's copy this and let's just change this to tuple. It should give us 3 in both cases. Okay, good. No problem. Works as we expect it to. We can check for membership in both of them. What we have here is how we're able to check for membership. So I have a simple print statement here that just says, oh, is Austin among my favorite cities? And then I put this placeholder called the format method in strings, and I'm able to just check this condition. Yeah, I'm essentially just checking for membership. It's going to return true or false, right? In both cases, it's true in this case. What's interesting here is I use this in operator to check for membership in both the tuple and the list. So you see there's a similarity there. We're able to check for membership between tuple and a list, very similar. So what if I no longer like Houston? I want to take Houston out and change it to, say, Dubai, right? I could do that. With a list, I can easily do that. That's not an issue. I just need to get the index, which is okay for the list. This index 0, this index 1, and this index 2. No big deal. Okay, so let's change Houston to another city. The list. So I'm going to take 5 cities, 2, change this to, let's say, Dubai. Okay, let's do that. So I'll show you that it actually changed. Okay, so let's run this. Can you see that we've been able to change it? Awesome. What if we did the same thing for the tuple? What would happen? Let's see what's going to happen. All right, so we copy and paste because I'm too lazy to type. So we change this to... Now already, even without trying to run it, if you're using an IDE like PyCharm, most modern IDEs would show you that this is about to blow up. Now, we already know this is going to blow up. Let's watch it blow up so we can learn something from it. Now, if we come here, it's supposed to show us why it's complaining. But now, I don't know if this is going to be captured on the screen or not, but it's seeing in PyCharm, it highlighted that, okay, this is not going to work. And it says, tuples don't support item assignment. Now, that's because you cannot modify a tuple after it's been created. And it says here, if you look at it, it says, replace, give you an understanding of when to use what media. If you know that you need to be able to change the data structure, fine, go with a list. You know, you've come down to between a tuple or a list and you know your modification is extremely important, go use a list. If you don't care about modification, yeah, stay with the tuple, that's fine. So I'm going to run this and we know it's going to give us an error and we'll learn from it. We see the error here. And like I said, you learn a whole lot from errors. So whenever you see this kind of error, don't be sad. Don't be in a rush to go type in ChatGPT. The very first thing you should do when you see a traceback is it tells you, okay, what is the file where the problem comes from? Okay, we know the file is a file I call learn tuples line 30. Okay, where's line 30? Oh, okay, this one, line 30. Great. So what's wrong with it? This is what you're trying to do. Oh, okay, so what's wrong with that? It tells me that what's wrong with it is this is a type error. What does that mean? Tuple object does not support item assignment. Yeah, that is one of the key differences between tuples and lists. Thank you for watching, and I'll see you in another video where we do some more cool stuff. In the last video, we deliberately got this error with the tuple, and we know it's a type error. So we know you cannot modify tuple after it's been created. We can just comment this out. Let's run this to get rid of the error. Now, what if you wanted to just create a tuple with just one element? You might think it's going to be very straightforward. And it is straightforward. I just want to show you that there's something special you need to do when you're creating a single element tuple. We'll call it single element tuple. And let's say we the name of maybe your first girlfriend or something. Say Alice. Problem. PyCharm is telling us, okay, why are you wrapping Alice in parentheses? Don't worry. Let's check the type of this. When we print the type here, we see that this is a string. Okay, how is it a string? It's in parentheses, just like we learned previously, right? Well, it turns out that for you to define a single element tuple, you need to put a comma. So this is not do this. I will say single element tuple. Now what's going to make this correct is this. That's it. Take this out. So to define a single element tuple, all you have to do for PyCharm and the Python gods to be happy is for you to put the comma right there. That's it. You know, these are some of the just the small things that can trip you up when you're first learning to program. This is just an example of how a single comma can make a mistake or can make a difference. So let's run this and I'll show you that it will be correct. Okay, the first one is a string, of course. PyCharm also complained to us, okay, well, these parentheses look kind of redundant. The second one is a tuple because we remember to put the comma right there. Thank you for watching and I'll see you in another video. So in the last video, I showed you how to create a single element tuple. Key thing is the comma. Yeah, I just want to dedicate this to tuple indexing. Even though we had touched it in the first video, I just want to make sure we have a dedicated video for tuple indexing. So yeah, we have a tuple of strings, red, green, blue. To get the first elements, this is index position 0, just like a list. Index position 1, and this is index position 2 or -1. Let me do this here, and we do, okay, let's run this. So we see red, green, blue, blue. Great. Now we have another tuple here called numbers, 0 all the way to 5. And if you want to slice it, let's just call this slicing. We can see here that slicing a tuple just acts like slicing any other object, right? So like a list. And for that, we have this, you know, a simple tuple called numbers. And we want this. Let's say we're interested in just this subsection. We know that this is, whenever you read it this way, whatever is before the colon, in this case 1, it starts from index 1. So this is index 1. Coincidentally, the numbers and the index positions are the same. So did that deliberately for it to be easy to understand. This is index 0, index 1, index 2, index 3, index 4. So if I say 1 colon 4, I'm just saying, hey, start from the element at index 1, which is 1, happens to be 1 in this case, and stop right before index 4, which is this. So right before is 3. So this will give us 1, 2, 3. If I'm like, you know what, start from the beginning, that's why I'm not going to put a number. Start from beginning, but don't go up to the index position 3. So, okay, beginning 0, 1, 2. This will give us 0, 1, 2. And this is a little different. Give us everything, pretty much, but only skip every second, only show every second element. So this is 0, start from 0, of course, 2, 4, and of course, there's nothing else after. So this is how you can carry out slicing a tuple in Python. Let me show you some of the outputs here. You know, this is what we expect. And let me run everything again. Cool. Thank you for watching, and I'll see you in another video. Hello. In this video, we're going to look at some tuple operations. So you see here, I've defined two, tuple 1 and tuple 2. Now you can do the addition operation, and it's going to give us just essentially merging both of them together. So let's run this and see what that looks like. Okay, we see it here. We have 1, 2, 3, 4, 5, 6. If I add something else, we could just add 9. Let's run it again. I see 1, 2, 3, 9. So it takes everything in this tuple and everything in this tuple and creates a new tuple here. So this is what we have. Now another one is when you use the asterisk, essentially performing a repetition. So you see here we have a single tuple defined. We know that it's a single tuple because we remember the comma, and then we multiply by 3. So we're essentially saying, okay, create this tuple with this variable name repeated tuple. Take what you've defined here and give us in 3 places. That's what we have here. Of course, we've looked at this in operator previously. What you have is you have a tuple of fruits. And here we're just checking, okay, is banana in this sequence, in this tuple sequence? True. Is grape in there? False. And there you have it. These are some of the tuple in Python. Thank you, and I'll see you in another video. Welcome. In this video, we're going to look at the only two methods that you have in a tuple, which are the index method. I'm sure you can guess what that does. And the count method. That is where a tuple gets very different from a list. List has several methods. A tuple just has two methods. So we're going to demonstrate each of these methods here. The first one is the index. So we'll call sample tuple dot index. And let's say we want to see the index position for element 2. So we can wrap this in a print statement. Print. And yeah, just run it. You see? Position 10. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Very similar to the index method for a list. Does essentially the same thing. Let's look at the second method, the count method. Let's count the number of times we have 8 in the tuple. 0 times. There's no 8 here. Let's count the number of times we have the element 1. So let's count it first. 1, 2, 3, 4. 4 times. Yeah, we see 4. And that's it. These are the only two methods for a tuple, index and count. Thank you for watching, and I'll see you in another video. Now in this, we want to talk about tuple unpacking. We see there 1, 2, and 3. Now with a tuple, you're able to do this. Extract 3 variables out of a 3-element tuple using this special approach. This is what we call tuple unpacking. This means that when we print this, we're going to get a 1. We print what's in the middle, it's going to be a 2. Print what's at the last part, it's going to be a 3. So let's see if that is indeed the case. 1, 2, and 3. And that's pretty much it when it comes to tuples. Thank you for watching, and I'll see you in other videos in this course. Thank you.